So in the previous video we talked about the multiplication rule. And the multiplication rule was used any time that we were looking for the probability of two things happening. So the probability of A happening and the probability of B happening. And we can actually extrapolate that, make it the probability of A, B, and C, so on and so forth throughout the whole time. But let's take a look at what happens if we're looking for the probability of A or B happening. So we've looked at AND statements. Let's look at OR statements. And this is kind of the easier way of writing it. There's the official notation way of doing it, and that's P written just like this. This right here is the official math notation way of writing the probability of A or B happening. So before I give you guys just the equation and you guys go off and do your thing, let's see if we can logic through and see if we can figure out a little bit more about this. So if we were to flip a coin once, the chance that we would get heads is 1 in 2. There are two outcomes that could happen. Either we get heads or we get tails. But now we're flipping the coin twice, and all we care about is getting heads at least once. So it should be easier to get heads. The more times you flip that coin, the easier it would be to get those heads values. So let's see if we can kind of get an idea for it. If the previous one was called the multiplication rule, let's see if this one's called the addition rule. Let's try and solve A by doing the probability of A plus the probability of B happening. So the probability that we get heads on the first time plus the probability that we get heads on the second time. Let's see if this works. So for the first flip, there's a 1 in 2 chance of you getting heads. On the second flip, there's a 1 in 2 chance of us getting heads. Now at this point, some people should be looking at this and feeling a little bit icky about it. Because if you add these up, you find out that the probability of it happening is 1. The probability of 1 is a very, very powerful thing, because that means it's guaranteed to happen. But think about this. Are you guaranteed to get heads once if you flip the coin twice? Take a shot now. Flip a coin, and the first time you have a 50-50 shot. So if you flip the coin and you get tails, we've already proven that this can't be the probability. This tells us right here that it's guaranteed. So where's the error in our logic? A lot of people might instantly say that it's not addition. But it turns out it is. The error in our logic is that we've included the possibility of getting A and B. So this is the probability of A happening on the of the probability of getting heads on the first flip. This is the probability of getting heads on the second flip. So we've double counted getting A and B. So we need to subtract that. So we're going to take that 1/2 and that 1/2. And in the previous video, we saw that in order to solve an AND statement with probability, it's that multiplication rule. So the probability of A happening times the probability of B happening. Simplify a little bit, you end up with 1 minus 1/4. So the probability of it happening is 3/4. Let's see if this one makes sense. Well, you got a 50% chance of getting it on the first flip. So more successive flips later gives you a higher chance. Well, 3/4 is higher than 1/2. So yeah, this makes sense. This doesn't make us feel icky inside because it's a logical possibility. It's not guaranteed. There's still a 1 in 4 chance we won't get heads at least once. But it's an option. And you can prove that to yourself. If you want to write out, now there aren't too many options here. On the first flip we get heads. So maybe on the second flip we get heads. Or we could get heads and then tails. Or we can get tails and then heads. Or we can get tails and tails. These are the 4 different outcomes we could have. Well, how many of them include at least 1 heads? 3 of the 4. So let's pull this out and see if we can get a look at a bigger situation. We're drawing a deck from our card from a deck, we're replacing it, and we're drawing another one. Again, it's very important that we say replace it, because now each time we've got 52 opportunities to get those. What's the probability of either card being a black or a king? So again, we're looking at an or statement. The probability of A happening or the probability of B happening. So we're going to look at the probability of A plus the probability of B minus the probability of both happening. P, A, and B. So the first option is that we get a black card. On a deck of cards, there's going to be two colors to it. We want one of those colors. Probability of B happening. Well, the other thing is a king. We've got 13 different cards, and one of those is going to be the king. If you don't believe me or if you don't know anything about those deck of cards, then what we can think is that we've got 52 different cards, and 4 of those cards are kings. You've got those hearts, diamonds, clubs, and spades. But now again, just like with the heads and tails, we have to be careful that we don't include the probability of them happening together twice. So the probability of A happening was 1/2, and the probability of B happening was 4/52, and that can be reduced. So I'm just going to go ahead and plug it all in together. And when you go ahead and simplify everything out, you're going to end up with 7/13. Again, let's do a quick idea. We're not going to actually draw out all the different possibilities like we did with heads and tails, but let's think about it. The probability of drawing a black card is going to be half, which, that'd be nice because you get the red cards, you get the black cards. The probability of drawing a black one is 1/2. But now we're also including those 3 other kings. So it's going to be slightly more than 1/2. 7/13 is slightly more than 1/2. If you go ahead and figure that out, it'll be 0.538, which is slightly more than 1/2. So if you draw 2 cards, then you're slightly more than halfway likely to draw a king or a black card. So the idea here is for an or statement, you're going to do that additive rule, but you also have to make sure to subtract the probability of A and B happening, because otherwise you include it twice and you should feel icky. Just like with that heads flip, we would end up with a probability of 1. It's never guaranteed that that's going to happen.